Hey guys, this is Miss Lily. I'm going to be talking about continuous and discontinuous graphs today. We're also going to be talking about in behavior. Okay? All right, if you have your guided notes, we're going to start by looking at what a graph is if it is continuous. Okay? A graph is said to be continuous if there are no breaks or holes in the graph. So basically, if you see this hand here on the graph or the little arrow, if I can trace the graph without lifting my pencil, that means there's no holes or breaks. That means the graph is continuous. Okay? If there are breaks or holes in the graph, then it is considered to be discontinuous. All right, there are also three types of discontinuity. The first type is infinite. That's when f of x increases or decreases infinitely. Okay, so if you can see this, it is decreasing infinitely. This one is increasing infinitely. And if you know f of x just means your y value. So it's going, the y-axis is up and down since this graph is decreasing and increasing in both directions. It is discontinuous because it's a break in the graph, but it is considered infinite. The next one is called a jump. And a jump is when you have a piece of the function and then you literally pick up your pencil and jump to a new part of the function. And then the last one is removable. And that's when f of x is continuous everywhere except for the hole. So you can tell this is continuous. There's an open circle there, and so that's a hole, and so that is a removable thing. The most important thing for this class is knowing if it's continuous or discontinuous, okay? So you don't really have to know the types as much as is it continuous or discontinuous. So be sure you know that if it can be traced without lifting your pencil, that is considered a continuous graph. All right, let's move on down the page. Let's look at some examples. So the directions say determine if the function shown on the graph is continuous. If not, identify the type and location of discontinuity. All right, so if we look at the first one, the first example, you can see that you can trace down to here and then it jumps and it goes on the other way. Okay, so we're going to say that the first one is discontinuous. And I'm just going to abbreviate that for now so we can get through the notes a little bit faster. Okay, where is it discontinuous? If you look at your x-axis, 1, 2, 3, 4, 5. So where x equals 5 would be the discontinuity. Okay, again, I just want you guys to be aware if it's continuous or discontinuous. The next one, if you trace the graph, you do not have to pick up your pencil. This one is going to be continuous. The next one, it has two pieces. Your f of x goes to infinity here and here. So this is called an infinite discontinuity. So this one is discontinuous as well. Okay. If you look, this line approaches 1. This line also approaches positive 1. So I'm looking at my x value here. So where x equals 1 is where it would be discontinuous. All right, the next one, number 4. If you look, you can trace this, and you don't have to lift up your pencil. That is continuous. Number 5 has a hole, so that is a removable. That is discontinuous because it has a hole. And if you look at your x values, you go 1 to -3, so x is discontinuous. Sorry, I didn't mean to put not equal to. It is not equal to that because it's not there if we were looking at the domain, but this one is discontinuous at -3. And if you look at number 6 is discontinuous because it's 2 pieces, and it also has a hole on this side as well. So this one is definitely discontinuous. It is discontinuous at, there's my y-axis, so 1, 2. And it has a removable point at 1, 2, 3, 4. So it also has a removable point at x equals 4. Okay? All right, so the main concept here, is it continuous or discontinuous? Now, if you have to pick up your pencil, it is discontinuous. All right, moving on. All right, the next thing we need to talk about is in behavior. Okay, in behavior talks about what the graph does as it goes up or down or left or right forever. So we have a x and y axis, so we're going to go both left and right and up and down. So we're actually looking at left and right as a direction and up and down as a direction. Left and right is going to refer to our x's. Up and down is going to refer to our y's. So to read this, as x moves towards positive infinity, if you look at the graph, as x moves towards positive infinity and negative infinity, in behavior describes what is happening to the value. So x going to positive infinity here, x going to negative infinity here. What happens to the y values? Okay, so if you look at this to describe the in behavior, look at the graph given. Okay, so as you take your pencil and the graph goes towards positive x infinity, so if it goes towards positive infinity, the graph goes down, so it falls. So the y values go negative at this point, so you can say f of x goes towards negative infinity. And then we look at the other side. If I go left of 0, I'm going towards negative x's. Negative x's would continue and you go towards negative infinity. So that's here. What's going to happen? When we look at our function, it goes up when it goes towards the left. So if it goes up, it's going towards the positive y's, which would be positive infinity. Okay? All right, so these values here will always stay the same. Okay? X is always going to the left and x is always going to the right. What you have to determine is the y values going up or down. So you're always going to have positive or negative infinity for these values. All right, so let's look at example. Number 7, 8, and 9 say describe the in behavior. Okay? It doesn't matter if you know what the function is. If you don't know what the type of function is, you can still determine the in behavior. So we're going to say as x approaches infinity and as x approaches negative infinity, what does f of x do? Okay, so f of x, remember, is our y values. Okay, so for number 7, as x goes to the positive, our y's go up. So that would be positive. As our x's go towards negative infinity, or as our x's go left, it's also going up, so that would be positive infinity as well. Okay? Now, number 8. Okay, I'm going to do this in blue so that we can see the different answers here. So as x approaches infinity, and as x approaches negative infinity, f of x approaches what? So if I look at x positive, that's my positive infinity, the graph's going down, so that's negative. And if I look at negative x's, so as x goes negative infinity, the graph is going down, so that is negative infinity as well. Okay? All right, now the next one is just a little bit tricky because it has 2 pieces. Okay? So we're going to look at this, and I'm going to put this in a different color so it shows up here. Let's try orange. All right, so we're still going to have the same concept. As x approaches the positive side, what happens to y? And as x approaches the negative side, what happens to y? So remember, our y values are just f of x. All right, my pen has stopped working. Let's see if it'll start back up. All right, since my pen's not going to work, I don't know why my pen's not going to work. Our f of x here, if we look as x goes positive, our y's are going up. So let's see if I can write with my finger. F of x approaches infinity. And then we look at as x goes to the left, or as x goes to negative infinity, f of x approaches negative infinity. Okay? All right, so continuous, discontinuous, and in behavior. All right, in the next video, we'll talk about as in behavior approaches a certain value. I hope this has been helpful.